In the last video, we started talking about the leverage points of climate change. Our conclusion was that they're really easy to identify, but difficult to do anything with. So that's exactly where a systems model comes into play. Let's look back at our model. The real dynamic that we're talking about is too much energy leading to too much heat. And the thing that's driving too much energy is too much greenhouse gas accumulation in the atmosphere. But let's get creative. Let's broaden our perspective a little bit. The energy leaving the system is only one half of the stock and flow, right? What if we could actually block the energy from hitting us in the first place? If we could block enough of it, it's easy to see with our model that it could offset the increased energy being trapped by greenhouse gases. And what if we took the same approach with regard to carbon in the atmosphere? Of course, we could produce less of it, but if that's too hard, if we have to charge our iPad and drive to work every day and we can't change that, we could look for ways to take that carbon dioxide out of the atmosphere, create a new flow called anthropogenic carbon removal, and lower the greenhouse gas stock that way. And in fact, that's just what proponents of geoengineering are suggesting we do. Their approach has been referred to as hacking the planet, and it consists of two main sets of strategies. The first is solar radiation management, and the second is called carbon dioxide removal. Let's start with solar radiation management. The idea of solar radiation management is to reduce the amount of energy that hits the Earth in the first place by reflecting some of that energy back out into space. This is where we find some of the goofier ideas. Giant sunshades assembled in space, clouds of mirrors circling the Earth, floating around in orbit. More realistic proposals have had to do with changing the characteristics of the atmosphere itself. That is, manipulation of the content of the atmosphere so that it reflects more radiation back out. Could that work? Let's look at a historical example. In August of 1883, a volcano called Krakatoa, located in Indonesia, exploded. But this wasn't your run-of-the-mill volcanic eruption, if there is such a thing as a run-of-the-mill volcanic eruption. It was a massive volcanic event. The explosion was heard thousands of miles away. Cubic miles of rock were thrown up into the air, and waves caused by the event went all around the world, and according to a report by the Royal Society of Great Britain a few years later, caused waves that could actually be detected by equipment at recording stations on the coasts of England and France. But the effect that we care about is the effect on the atmosphere. The same Royal Society observers, compiling reports from around the globe, described the appearance of a sky haze, as they called it, that spread throughout the tropics, and that by November of 1883 had reached the United States and Northern Europe. This haze, which we now know was fine particulate matter ejected from the volcano and suspended in the air, caused phenomena such as coronas, or rings around the sun, really intense, lurid sunsets, a perceived dimming of the moon, and the disappearance of dimmer stars from astronomers' observations. Worldwide, for at least the next 2 to 3 years as the material slowly settled out, these atmospheric effects were observable. This is all pretty spectacular stuff, but what else happened? It's estimated that all of that material suspended in the atmosphere reflected so much solar radiation that the world was cooled by greater than 1 degree Celsius in the year following the eruption. And it turns out that global cooling following volcanic eruptions is a pattern that repeats itself throughout history. This is the effect that geoengineers think that humans can replicate. To create a haze in the atmosphere, create an artificial volcanic eruption. One technique for doing this is to have airplanes spray a class of sulfur chemicals known as sulfate aerosols into the stratosphere. Researchers estimate that this could be carried out for less than $1 billion and would have to be repeated every 4 years, but would have the potential to reduce incoming solar radiation by 1%. Other researchers have proposed cloud whitening, the use of a fleet of unmanned self-propelled ships that would pump water into the cumulus clouds above the world's oceans. By increasing the amount of water vapor in low-lying clouds, more solar radiation would be reflected from the planet. The second major technique, carbon dioxide removal, likewise has some more and less plausible variants. Ideally, we just sweep carbon out of the atmosphere, suck it up, and pump it deep underground, storing it in rock formations where it couldn't do any harm in the atmosphere. Unfortunately, we don't currently possess the technology to do that. We can imagine some fanciful representations of it, artificial trees sucking the carbon out of the air, but we haven't invented it yet. But why use fake trees when there are real trees? One way of combating climate change that has long been recognized is the reforestation of deforested land. Trees, growing and sequestering carbon into wood over hundreds of years, are a great way to take carbon out of the atmosphere and store it for the long term. Although reforestation contributes to a reduction in greenhouse gases, the geoengineering version of this story takes place in the oceans. Unlike trees, carbon is taken up in the oceans by algae, which have very short lifespans. When algae die, some of them sink to the floor of the ocean, and the carbon sinks to the seafloor and becomes sequestered in the dark and cold of the deep ocean. It turns out that algae in the ocean are extremely nutrient limited. In particular, algal growth is known to be limited by the availability of iron. So one suggestion has been that if we fertilize the ocean with iron, we should be able to stimulate blooms of algal growth, which will ultimately move carbon from the atmosphere to the seafloor, taking it out of circulation.